1993 and 1995, and the original inventory was completed in 1997. We ended up purchasing new aerial photography in 97 and 2007, and we did field data between 2007 and 2009. And what we were looking at is more of an operational inventory where we could actually look at individual timber stands and be able to more schedule and have an operational inventory where we could look at where these stands occur out across the spatial area. We wanted to have more data on the birch volume, quality and location. We wanted to reflect changes in land status and vegetation cover, and fires is a big one. We've had a lot of fires in recent years, and we wanted to cover that. Like I said, we wanted to accurately locate stand polygons across the project area. And this is where it's important. If you want to try to have any type of utilization, you have to know where the resource is and have it accurately located. And then we've developed an internet mapping site where the public can query these stands on a regular browser on an internet map and find data on the individual stands. So the update included volume and tree growth summaries for Kantishna, Fairbanks, and Delta. So that's extending all the way out to the Kantishna River and up to Delta, and then we had a separate volume summary for the Tok area. We had a total of 887,000 roughly acres of timber, a total of 1.6 billion cubic feet, 34 million tons, and 3.6 billion board feet were calculated for this area. We're still working on some of the vegetation typing and the non-forests and the reproduction in the dwarf forests. We're going to do that analysis and timber typing using eCognition, which is an automated software that has pattern recognition features that can use imagery to analyze where these forest stands are. And the acreage of these vegetation types will be incorporated into the final report. And then, like I said before, the new version of the internet site is on, and it has acreage and query tools available. And here's a shot of some of the new imagery that we acquired. This was purchased in 2007, and our original inventory, the imagery was relatively coarse. It was at a scale of 1 inch to a mile, and so individual timber stands were somewhat difficult to map. I mean, you could tell the difference between spruce and hardwood, but telling the difference between birch and aspen was quite difficult, and that was one of the reasons we wanted to get this updated imagery. And what we found was it was perfect timing, because we got this imagery flown in 2007, 2008 in the height of the aspen leaf miner. And so the aspen stands just jumped out on this imagery and would not have been nearly as easy to define if this hadn't been the case. So that you can see that the silver looking stands there is basically those aspen leaves that have turned silver because of the leaf miner. And so they were really easy to pick out, and the original timber typing just more or less had this typed completely just as hardwood, so you weren't able to break out which stands were birch and which stands were aspen. And so then when we ran the data on these individual stands, our birch closed, we have about 180,000 acres, and the data definitely bears that out. We have, in those stands, we have about 270 trees per acre of birch, and then much smaller amounts of the minor species. And then conversely, in the aspen stands, we have about 300 trees per acre in those stands with some minor species. So before, it would just be called hardwood, and you'd say, okay, well, I have about 400 trees per acre, and some of them are aspen and some of them are birch, whereas this, now we have the individual stands categorized. And where this is important is that the value of those two species is quite a bit different. The birch is desired for fuel wood. It burns hotter, higher BTU, and the aspen is somewhat lower and less desirable. So separating those out and using them for biomass. The aspen right now, we have very little utilization on those species. And when you harvest aspen, it just comes back very strongly, natural regeneration, and it also provides very good habitat for moose and other critters. And then the other thing we wanted to improve on the inventory was looking at the individual growth rates of the trees. And this is important in determining whether your forest harvest is sustainable or not. So we had the software that we're using to process the data utilize the diameter growth, bark thickness measurements, and diameter and height relationships to project the growth of the standing volume. And this really helps in determining whether your forest harvest is sustainable or not. And so here's some comparisons that we had between TOC data and then the data from Kantishna, Fairbanks, and Delta, which was pooled. And you can see the difference in some of those timber types from TOC. Now TOC is much higher elevation. The base elevation is about 1,500 feet there. It's a little drier site, and you can see the productivity is somewhat behind what it is here in Fairbanks. And so the data is separated between those two areas, so we can analyze the resource more accurately. And then this this is a shot of the difference in the height growth, and this is real evident. If you look on the top line there, the white spruce. For the Fairbanks area, 15-inch tree, you're looking at roughly about 80 feet tall. Whereas that same tree in the TOC area is a little less than 70 feet. So there's quite a bit difference in site index between the Fairbanks area and the TOC, and thus the productivity of the ground. And you can see that for the other species too. They're generally lower in the TOC area than in the Fairbanks area. From that increment core data and the height growth, then we can project what these individual timber types are growing. The net growth is ranging from 0.5% to almost 5%, and that actually translates into quite a bit of volume growth. If you're looking at it in terms of cubic feet, it's ranging between 23 and 55 cubic feet per year, so that's almost about 1/2 cord per acre per year. In tons, for the Kantishna Fairbanks Delta, it's ranging up to about 1 ton per acre per year. And then you can also look at it in cores, and it's about 1/3 of a cord to about 3/4 of a cord per acre per year. So it's showing that the forest obviously is growing, and it's growing at different rates between your individual timber types. So if you know that when you're projecting sustainability, depending on which timber types you're harvesting in, then you can project how much incremental growth you have. And then we calculated the allowable cut for this new update. Now this is still just reflecting the pole timber and the saw timber stands only, since we haven't yet to classify the regeneration. But for the Fairbanks area, we're looking at about 3,200 feet, or 3,200 acres per year. Total in the Tanana Valley State Forest, we're looking at about 9,000 acres per year for an allowable cut. If we include the regeneration stands, this is likely to go up probably about 30%. So this is kind of preliminary at the immediate time. Currently in Fairbanks, we're harvesting about 500 acres a year from the Division of Forestry in our timber sale program. So we're significantly under the harvest amount. And for the Fairbanks area, we also, some of our harvest takes place in the Kantishna, which is down below Tanana on the Tanana River. So we're including some volume there. So in the Fairbanks area, so we're looking at about 68,000 cores of an allowable annual cut. The other big portion of the forest that I hadn't really included in the inventory, but we're looking at this much harder now because of the biomass issue, is the black spruce stands. Now, generally, those are about 20% of the state forest land. So if you look at those acres, you know, we have about 2.5 million acres of state forest, so we're looking at about 500,000 acres of black spruce. We're currently mostly, the operations that we have in it are mostly designing fuel breaks. And this picture here is off of Old Murphy Dome Road, and this is a fuel break that we put in a couple summers ago. This area currently, what we're doing with these fuel breaks is we're shearing these things off in the wintertime with a big dozer with a shear blade, and then windrowing the material and burning it. And we've done some estimates of volume in these types of stands, and we're looking at somewhere around 12 tons per acre, so that we're just basically burning up. So this is material that definitely could be used for biomass and is relatively close into Fairbanks, because this is where we're doing our fuel breaks, generally where we have infrastructure to protect. And then what we're trying to do in these fuel breaks is get site conversion, where if we warm up the soil in these black spruce stands, then we're hopefully transitioning them over to hardwoods, which are less flammable. So one of the issues, though, we have is developing harvest techniques to get this type of material, and we've been investigating the use of this piece of equipment from FECON. It's called a bioharvester, and we're trying to get some trials maybe this spring up here in Fairbanks to see how this would operate in our black spruce stands. This is essentially, it's a mulcher, but it also collects the material. And so if we could mulch the black spruce and collect it at the same time, this might be a good source of biomass. And then once you have the growth rates and you know where your timber stands are, then you can work on these working circles and determine what type of operable biomass you have. And we did this study for Kenny Lake. They were looking at firing the Kenny Lake School with a wood boiler. So we did an analysis down by Kenny Lake near Glen Allen. And we just broke the area up into 10-mile radiuses around the town and looked at the resource within those radiuses to decide, you know, what is operable, knowing that as you go out from the town, it's going to get more expensive for hauling, but your volumes are going to change because you're going to be covering more ground. And what we also did in this project is we limited the area to what we determine is operable biomass, because down in the Copper River Basin, there's a lot of incised rivers that are difficult to cross, and so we ended up limiting the forest area to just operable ground. And what we did in this project is we took a look at the delivered cost of a cord of wood and looked at, okay, well, as you haul that cord further and further, the cost goes up. And so then you can run a little regression equation and get the value of that cord as you're going out in radius. And then you can translate that into delivered cost per ton. And so this will give you an idea of how far out from a facility that you could go and still have what we consider as operable biomass, because the material is expensive to haul, and even though you may have the volumes of it, if it's not located in proximity of where your facility is, it may not be economical. And then so we ended up with a bar chart that had basically the annual volume availability, and this was using the sustainable yield of these different timber types and the radiuses out. And so from Kenny Lake, we were looking at, if you went out 50 miles from Kenny Lake, you'd have close to 3,000 cords per year that you could sustainably harvest. And so you can see the difference of how much it goes up as you go up further, but then obviously your costs are going to increase in those distances. And then finally, we developed this website. We've put a lot of time into this, and this website also has a lot of other data besides timber data. It has a lot of wildfire. It's great for hunting. It's got great photos in it and roads, and so we're trying to get all our timber inventory data onto this. And this is in a standard browser at www.forestrymaps.alaska.gov. And so this will work on just with a regular browser. And essentially it's a mapping website with different layers that you can turn on and turn off that have roads and fires and all different types of resource information. But also within it, it has the boundaries of the Tanana Valley State Forest, and it also has our logging road and other roads system on it. So if you're interested in a particular area where you want to harvest biomass or other timber resources, you can go into those particular area and say, okay, well, I'm interested in this road system. And you can zoom into those areas. You can display the timber stands on it. So these are all the timber stands that have been identified. And then each one of these corresponds to a particular volume and acreage. And so you can say you're interested in just a particular area along the road system. You can select those timber stands, and it runs to the database and essentially summarizes the volume and the acreages of all those stands that you circled up. And then you can run this out to Excel or to different databases. This is a utility in there that you can run it right out to a bar chart. So in that one little area there, we had about 200 different timber stands that were identified, and we ended up with about 28,000 cords of birch and 50,000 cords of aspen in there, and then almost 9,500 mixed. So this is a very quick way to determine where volume is and where it's available in different parts of the state forest. And this website covers all the way from Kantishna River out to Toke, and then we also have another application for this in the Glen Allen area. And so our inventory program, we're trying to get this website posted for each of our area offices. We have offices in Palmer and down in Ketchikan and Soldotna, and so we want to have this information available for these other resource areas. And then this is just a shot of the type of timber that we have available. This is in the Toke area, and you can see that this is one of those stands that has a really thick moss component, and we have a lot of this type of timber that's kind of stagnant that really responds well to opening up the site. So that's all I have, and I guess we'll hold off on questions until we have the other speakers.
Great, thanks, Doug.
All right.
And now we're going to have Steve Sparrow come up and speak from the University of Alaska School of Natural Resources and Agricultural Sciences.
Load it up here. Whoops. What's going on? Where's the, is it 7? No. Marcus, I can't find the button to get it,
It's up there on the left, the front slide. Got for last, yeah.
oh, okay. Yeah, I'm used to the little wine glass.
Tutorial, I apologize.
Okay, well, sorry about that. As Julie mentioned, I'm Steve Sparrow with the UAF School of Natural Resources, and I get well, there's been a lot of interest lately, and sort of the question is, can we actually grow biomass feasibly in Alaska? So I just began a research project recently to start to try to answer that question. I'm going to tell you a little bit about that today. I wanted to throw out this term, lignocellulosic biomass. I know it's a big fancy word, but it's a term that's used a lot in the industry. What that means, there's lots of different kinds of biomass that people grow. And of course, you've all heard about corn and sugarcane and that sort of thing. That's grown primarily for ethanol. There's also biodiesel. You know, you probably heard a lot about soybeans, oilseed crops in general being grown for biodiesel purposes. We actually have a research project at UAF looking at canola as a potential crop for use as biodiesel. But what I'm looking at is what in the industry is referred to as lignocellulosic biomass. That's basically what that means is fiber. We're talking about wood, grass stems, and that sort of thing. In other words, it's the material that's made up of lignin, cellulose, hemicellulose, and that sort of thing. And that's the research I'm doing and what I'm going to be talking about tonight. We generally split lignocellulosic biomass into sort of 4 categories. There's wood residues, which are things like sawmill waste, well, mill discards, things like that. Municipal paper, wood waste is considered lignocellulosic biomass, and there is interest in Fairbanks. As a matter of fact, I think China Power is talking about building a plant to burn that sort of thing. There are agricultural residues, which is basically the residues left over after a crop is harvested. We're talking about things like corn stover, the sugarcane fiber that's left over after the juice is squeezed out, grain, straw, that sort of thing. And then the last, which is what I'm going to talk about, are dedicated, what we call dedicated energy crops. Those are crops that are actually grown for the purpose of producing energy. Question is, well, why bother to grow it? Doug already told us that, you know, there's quite a bit of biomass out there on the land, and it's, you know, reasonably productive. But, you know, one of the questions is, can we actually grow it feasibly? Can we produce more by growing it than if we just allow it, you know, if we just harvest what's actually out there? And of course, you know, it might be, and I noticed I've highlighted the may here because we don't know this yet. But growing biomass might be a cheap substitute for expensive energy, especially in rural Alaska, where energy is real expensive. It may be a sustainable source of energy. Like I say, we don't know that for sure, but it might be. And then it might sequester carbon, or at least be carbon neutral. And again, we hear a lot of talk, people make statements about how growing biomass is carbon neutral, but we really don't know that. And so some of those questions we hope to answer as we go through our research. What are some of the candidates for bioenergy crops? Well, I'm sure you've all heard about some of the grasses, like things like switchgrass and miscanthus. These things, they grow like crazy. They'll grow up to, you know, pretty close to 10 feet tall in a single year. But and there's a picture here showing you know, a person standing next to switchgrass, and that's, like I say, that's a single year's growth. Stuff produces a tremendous amount of biomass. You know, there have been reports of 10 to 11 tons per acre per year. But they're warm season grasses, and we found they simply don't grow well in Alaska. There's several other warm season grass crops that are being looked at for biomass, but again, they don't do well in Alaska. There's a grass called reed canary grass, which is grown. It's a cool season grass. It's grown in Sweden as a biomass crop. But it's actually considered an invasive weed in Alaska, so we're a little leery about playing around with it too much, although I do have some in some trials. And we're finding that in interior Alaska, it doesn't survive the winters very well. So I don't think there's much potential there. So that brings up the question, well, what about native Alaska grasses? And so we're starting to do some work on native Alaska grasses. And then sort of the other category of candidates for bioenergy crops are woody species. And here we're talking primarily about things like willows, poplars, alders, things like that. The nice thing about willow is it's adapted to cool climates like we have here in Alaska. It's usually harvested on about a 3 to 5 year rotation, depending on the climate and the soils and that sort of thing. It can grow in low fertility soils, but it generally does a lot better. Yields are a lot higher on good soils. It can produce, and this is research from temperate climates, not Alaska, but it can produce high yields. Yields of up to 10 tons of wood per acre per year have been reported. So there is a lot of potential there for something like willows. But it requires a lot of management. The establishment is fairly labor intensive, for example. Weed control is a problem. So it does take some management. You don't just go throw the stuff out on the land and let it grow. Hybrid poplar is another woody plant that there's been a lot of research done, a lot of interest on, and as a biomass crop, it's extremely fast growing in some climates. It's usually harvested about every 10 to 12 years, so it's a fairly long wait before you get a crop, but it can yield up to about 10 tons per acre per year. So we're talking a lot of wood being produced there. And this is a picture of a one-year-old hybrid poplar stand in Washington State. And notice this stuff is pretty impressive. We're talking 15 feet growth in a single year. So a lot of material being produced there. Well, what about Alaska? Well, as I mentioned, there's a lot of interest in growing biomass here, but there's almost no information. And so that's what we've set out to do, is to start to get some information on productivity or potential for some of these plants as biomass crops. And so we're looking at both native grasses and some of the woody species. We're currently studying 12 species of willows, both native and non-native. It says 3 poplar, actually it should say 2 poplar species, a couple species of alders, and then several grass species. Preliminary studies have indicated that for the woody species, felt leaf willow and poplar seem to have the most potential, although it's a little early to really say that for sure, but that's what preliminary results indicate. And then several native grasses are showing some promise anyway. And we're looking at things like establishment methods, something called coppicing management, which with willows, generally, if you cut it, it'll, if you clip it at about 4 or 5 inches above ground height, it'll cause it to send out new sprouts. And so rather than 1 or 2 stems, you'll have multiple stems. And that's usually referred to as coppicing. And so one of the questions, though, is when's the best time for coppicing? Do you do it, at the end of the first year, or do you wait several years? How effective is coppicing in increasing biomass yields and that sort of thing? So we're looking at that. We're looking at things like harvest management. What's the proper time of harvest? How many years do we have to let it grow before harvest? What time of year? Some of those kind of questions. So what kind of results have we gotten so far? Well, we've done several measurements, both under non-intensive management and in some of our intensive management trials, which we're doing at UAF. There's a lot of land in Alaska under something called the CRP, or Conservation Reserve Program. It's land that's been taken out of farming. It's marginal land that's subject to erosion and that sort of thing. So it's been taken out of farming and put under permanent cover. Well, a lot of that land, you drive by it, and it looks like it's covered with willows. And so one of the questions is could we actually use that as a source of willow biomass? And so we said, okay, let's go sample it. It's normally mowed well, as a matter of fact, the law requires it to be mowed on a 3-year cycle. So we sampled CRP land that was in its 3rd year, and, well, we were really pretty surprised. We got, the total average yield was about 6 tons of wood per acre. That's total now, that's not per year, so that's 3-year growth. So kind of discouraging for CRP land. We also, I know some people have said, well, what about the Chena flood control project? There's quite a bit of land there. It's under permanent cover, and they mow it on about a 3 to 5 year basis. A lot of it is grown up to willows. And so, and again, you drive by there, and it looks like there's a tremendous amount of willow out there. Well, we measured it, and again, we got a yield of about a ½ ton per acre. So pretty discouraging there. Well, what about we also did some sampling this summer. Most of you probably remember back in 2001, the pipeline was shot in October of 2001 up by Livengood. Well, in 2002, that area was planted. Apparently, the area that had the oil spill on it was the oily soil was removed, the soil was replaced, and they planted the willows. So we went up there this summer and sampled some of that, and we haven't had time to analyze the data yet, so I don't know what the yields were. But this is what it looks like. And you look at that, it looks pretty impressive. You walk out in it, and I don't think the yields are going to be all that high. but at least, you know, that we'll find out when we get the data analyzed. What about under more intensive management? Well, like I said, we're doing some trials at the Fairbanks Experiment Farm. We're actually growing willows and poplars and grasses under intensive management. What I mean by intensive management, we manage it under high fertility. We maintain high fertility in the soil. We control weeds, control moose damage, that sort of thing. So our plots are pretty small yet, so we haven't actually harvested any of the woody species plots, but we've done some non-destructive measurements. In other words, we measure the height and the diameter of the stems, and then we use a model to get a handle on biomass. And our estimate is that after about 3 years growth, we're getting 1.5 tons per acre of wood. In the northeastern United States, they get about 4 to 5 tons per acre per year in their first rotation. So it sounds pretty discouraging, doesn't it? Does that mean, hey, we can't grow willows as biomass in Alaska? Well, maybe not. We know, and Doug mentioned that, well, at least aspen and that sort of thing will regrow pretty rapidly after they're cut. Well, willows do the same thing. Once they're well established, you go out and cut a willow, and you get a lot of regrowth the following year. And this is a picture showing some willows and some small plots we have at the Fairbanks Experiment Farm. This is a single year growth of willows. So this plant here was cut in fall of 2009, and this is a picture taken last week. And notice this plant's about 10 feet tall. I don't know what the biomass is yet. We haven't harvested it yet, but pretty substantial regrowth there. But so some of the questions are, well, how long does it take willow to become well enough established that you can get that kind of regrowth? And what is the optimum rotation time to get that kind of regrowth? And so some of those kind of questions we're trying to get a handle on. And it'll be a few years yet before we have any answers to that. So, you know, I can't really tell you what the potential is there. What about grasses? Well, there's several potential advantages to growing grasses for biomass. It's shorter harvest intervals. You get a crop, I mean, you get a harvest every year. They're generally easier and cheaper to establish than something like willows or poplars are. And they normally probably require less management. That's not 100% true, but you know, it often is true. These are just pictures of some of our grass plots. The top one there is hairgrass, and the bottom one is slender wheatgrass. Both are native grasses found in Alaska. Certainly nothing like you see with switchgrass. You don't get those grasses 10 feet tall, but this is a picture of taken last week of some of our plots at the Fairbanks Experiment Farm, and they certainly look, you know, they're pretty respectable looking anyway. Well, what kind of yields can we expect? Well, we found in some of our preliminary work that we've gotten up to about 4 tons per acre per year. And I really think this year we're going to beat that. This was a fairly wet year. Our plots are well established now, and so I think we're going to get considerably higher yields than that, you know, in this year. But what can we sustain? Like I say, it's really too early to say at this point. So, bottom line, it's really too early to say much about what the potential is for growing biomass as a crop in Alaska. Maybe come back and ACEP can have you back in 3 or 4 years, and we'll be able to give you more answers. But that's kind of hopefully a nutshell of what we're doing and you know, where we're at. So I guess we're supposed to hold questions, so I'll let our next speaker come up, and then if you have questions, I can try to answer them. So Chad, I think you're right.
And our final speaker is Chad Shoemaker from Superior Pellet Fuels.
Good evening. As mentioned, I'm Chad Schumacher. I'm the General Manager for Superior Pellet Fuels. Basically, we are a brand new company here in the area. We built this pellet facility starting in May of last year. and we are planning to be operational, as noted here, this month. So we will be actually having material available for sale by the end of this month. Now, I began working on this project in 2006, analyzing the entire facility operations and really taking a look at a lot of the information that Doug has provided with the raw material availability here in the Fairbanks area. The local forest here is a fantastic raw material supply for the system that we need here and the volumes that we plan to produce on a consistent basis and sustainable basis. Now, what I'm going to do here is just provide a quick tour of the entire pellet facility, and then after that I'm also going to talk about some of the economics that come down to analyzing the raw material side of our operations. Now, this is the view of our pellet facility as you're driving up on Cobb Road. The facility is located between Fairbanks and North Pole, about a mile southeast of the first Badge Road exit coming from Fairbanks. Now, the raw material supplies that we are using for our facility are all of the same species that everyone's been talking about here. We will handle both white and black spruce, the white paper birch that's available here, and then the aspen and balsam poplar, or better known cottonwood, that people tend to call it up here. The raw materials, where we're receiving our products from, number one, we're receiving all of the residual materials from the local sawmills. Their sawdust, their wood chips, their shavings. That way, all that material is essentially a waste product that's coming off of their finished product in their sawmills. We're able to utilize that and make it into a valuable product. Our secondary raw material supplies are coming off of fire mitigation and land clearing projects. Working with some of the local land clearing contractors around the area, as well as the opportunity to utilize some of that fire-killed timber that's up here. There's a tremendous supply of raw material there that really has no better use. You know, Doug had mentioned that aspen and balsam poplar are not at all a desirable material when it comes down to fuel wood harvesters. That is absolutely the case, except for in our situation where we are drying all of the product that goes into our pellet manufacturing. By drying that material down to a controlled moisture content of between 6 and 7%, it actually has a fantastic BTU value, comparable to every other species that we're looking at putting into our mix. The third option for us is obviously purchasing actual logs. Now, we're not interested in picking up any material that could be used for a higher quality material, such as sawmill or saw log or house log production. Now, what we're looking for is material that has you know, a lower grade quality, whether it be from heart rot or whether it be from the material or the logs are not straight, really can't produce a higher quality product. That's the type of material we're shooting for at our facility. Now, the material that you're seeing here in these pictures, this is just a couple different examples of our raw material supply. Now, the first picture here is a log deck that is actually sitting on our property directly behind our wood pellet facility. Now, those are locally harvested spruce logs that did not meet a quality spec as they were being as the loggers were looking to turn those into the local sawmills. So, because they didn't meet that spec, they were able to bring them by to our facility and still be able to get something out of that product. The second picture in there is actually a picture of the shavings at Northland Wood Sawmill. Now, that material is ideal for our production because there is no additional processing that goes into that. Not to mention it's a waste stream for Northland Wood, so it's extremely economic for both us and Northland Wood to get rid of that material. this is the equipment that we utilize in our yard to process any of the logs that come into our facility. Now, the first picture here is a portable wood chipper. Its primary location is at our wood pellet facility and will be stationed in our yard there, but is also available to transport into an area such as one of the areas that Doug had mentioned where they're doing some black spruce clearing. We'd be able to move that system right in there, chip up any of that material that was harvested right there, and then transport it ourselves rather than going into that area, because small black spruce, the volumes are very difficult to transport in log form. Now Doug was also looking at the better option with that Fecon machine. That does exactly the same thing that our wood chipper does, and delivers a clean product, because that Fecon machine harvests the material, picks it up, keeps it off of the ground as it's processing it, and then keeps a clean chip directly into the chip van that's pulling. So that is an amazing program that we definitely hope to see establish up here in the Fairbanks area. Now, as the material is feeding into our facility, we use a front end loader and feed the first raw material in chip form directly into this reclaim bin. Now, this bin holds about 15 yards of material, and we have to fill that 3 times every hour as we're operating. This system has a drop-down gate to control the flow of the material, so that we know that we're seeing a consistent flow of the raw material as it's feeding into the system. From that reclaim bin, it goes over a conveyor system and then feeds directly into our first hammer mill. Now, this first hammer mill is a 250 horsepower machine, has between 20 and 30 40-pound hammers that are swinging and breaking down that material into less than 1 inch in diameter size. From this hammer mill, as soon as that material reaches that 1 inch diameter size, it falls through and goes on to our second hammer mill, which takes the material down to less than 1/2 inch. Now, that's a very efficient size for us to feed that material into our drying system. So we take that 1/2 inch material and feed it through this cyclone system, which separates it separates the raw material from the air and the moisture as it's coming through that process. That raw material falls down into a storage bin and then feeds directly into our rotary drum dryer. Now, this rotary drum dryer it is 40 foot long, 8 foot in diameter. It can dry between 12 and 14 tons of material every hour. So that material is coming through there roughly estimated at about 50% moisture content. By the time it leaves this system, it's between 11 and 12% moisture. And that material gets pulled up by this vigor cyclone, and that material, at that point, that's where the material separates from the moisture, and the material falls down and feeds directly into the building. We separate that moisture through a steam emission stack where that material comes out of the process. Now, the material feeds in from that rotary drum dryer into a pre-bin that sits over in the corner of this picture. Now, that pre-bin is basically a storage capacity, so we can store raw material and make sure that we don't have to shut down our production if we have to shut down our dryer system for a little bit of minimum maintenance. We have essentially 1 hour's worth of raw material storage right here, where we wouldn't have to shut down the pellet mills and the production side of things in the event where we have to do some minimum maintenance on the other portion of it. Now, these are 2 Buehler pellet mills that we have here, and they're each 300 horsepower pellet mills, can produce about 3 tons of wood pellets every hour each. So our facility is producing approximately 6 tons of wood pellets every hour, which on a 24-hour basis, we're estimating to produce about 120 to 150 tons every day. Now, these are the components on the pellet mill. You're basically looking at the rollers and the die. The rollers basically push that raw material directly into the die and excrete a wood pellet out of there. That wood pellet comes out at 3/16 of an inch in diameter, and they're roughly about ½ an inch long. From the pellet mill, we move them over to a cooler system because they come off of the pellet mill at about 180 degrees. We send them through this cooling process, which brings them down to less than 100 degrees before we put them into our bulk storage. This is our bulk storage. We can hold about 100 tons of finished product in this storage bin. And from that point, that allows us to only have to run our bagging line about half of the operating hours that we're operating the rest of the facility. And from that point, after the storage bin, we move it over into a form, fill, and seal machine, which actually does our automated bagging line. Now, from this point, that is the only, after it comes off of this bagging system, it's the only manual portion of this entire project, where our operators will have to manually stack all of those bags onto a pallet and prepare them for delivery or shipment out of the facility. Now, one thing I wanted to point out here, we try to be as efficient as possible at our wood pellet facility, and one way that we're doing that is by recycling all of our fines that don't meet our quality spec as it's going through our pellet operating line. There are 2 points here that have vibrating shaker machines that separate those fines, and we recycle those fines all the way around the facility and back into a finish hammer mill where we take that sawdust that doesn't meet our quality spec and actually grind it down one more time into a wood powder. Now, we're taking that wood powder, and that is 97% of the fuel that we're using to dry all of our wood product as it comes through this system. The other, I mentioned 97%. The other 3% is a propane igniter fuel. We use that propane to build our temperature up very quickly in our burner system, and then cut it back to nothing but a pilot light as it's operating for the majority of the hours of operations. The burner that you see in this picture is actually a 24 million BTU burner that we use to dry all that product. It operates between 1250 and 1400 degrees. So that is this is the machine that we use to dry that 12 to 14 tons of raw material product that's going into our facility every hour. Now, the biggest question: why wood pellets? Number one, economics. The Fairbanks area, over 90% of the residential users use fuel oil as their primary fuel to heat their home in the Fairbanks area. When you compare those costs to our sale price of $295 a ton of wood pellets, the break-even cost there on an 80% efficient system is $2.28 per gallon. Now, that is a price that I hope we someday see, but I'm pretty skeptical that that's going to happen anytime soon. The second point here, environmental. Wood pellets are the cleanest burning solid fuel available in the United States. That is a major selling point when we're looking at an area such as Fairbanks that is a non-attainment location when it comes down to the PM 2.5 challenges that we face here. It's an excellent substitute when you're comparing changing out some of the wood stove systems that the Fairbanks Borough is currently looking at doing. It is a renewable resource. Doug pointed out that the area here, the Fairbanks portion, was greater than 3,000 acres per year on a sustainability level. Now, this facility, if it was to operate 100% on whole tree harvest activities, we'd be looking at less than 1,500 acres on an annual basis of harvest. Now, I mentioned that, and I should also mention that we're getting raw material from all the way out to Delta Junction and even to the toke area. So, you know, transportation is the biggest expense or biggest portion of the cost of raw materials these days. So the more material that we can utilize from the area's sustainable forest, the better off this this facility and the lower the cost of heating for all the residents will ultimately be. Now, it is a locally produced product. It's easy to maintain. It's very easy to handle. You know, we produce our product into 40-pound bags, and you know, that 40-pound bag is pretty simple to dump into a bucket and load into your hopper. I was at my one of my friend's houses here just a year ago, and his 80-year-old grandmother was loading their pellet stove. So it was pretty entertaining to see that she said that was her chore every day, and she absolutely loved it. And you know, it's something that makes this material really easy and readily available for anyone to use in heating their home. That is all of the presentation that I have. But the last thing I wanted to focus on was the raw material costs. You know, I mentioned that transportation is a huge part of the raw material cost when it comes down to it. And anything that we can do to utilize a raw material that is closer to the Fairbanks area is ideal for us and for the industry and for the heating industry. You know, Doug and his state forestry are doing everything they can to make material available to us, but you know, it's definitely a challenge to get the economics down. You know, to make sure that this is a, you know, economic facility, and we can keep our costs low to make sure that a product is available.
The ratio of energy output includes the drying and the milling, the energy going into the drying and the milling.
The drying process and the milling. It is our facility is a high energy user, or high power user when it comes down to it. The BTU value output, I don't have that direct comparison for you at this point, but I can tell you that you know, the BTU value of the wood pellets that we're producing is greater than 8,000 BTU per pound, you know, with the raw materials available here, we actually expect that to be about 8,300 BTU per pound. I don't have a direct comparison for the energy consumed at our facility to give you that answer.
Mr. Schumacher, I was wondering, is it possible to use waste paper to produce pellets?
It is possible to produce pellets. It's not possible in our system. You know, there was a wood and paper or biomass pellet facility operational out on Eielson here, what, 5 or 10 years ago as it was operational. The facility's no longer there, but it definitely is a possibility. It doesn't work in our system because of the type of machinery that we have installed at our facility. Ours is 100% wood fiber only.
Can you take or receive yard waste or wood construction debris?
We cannot, solely on the concern of contamination. We have magnets and rock traps throughout our system to make sure that you know, damaging items such as nails and other metallics don't get through our process, but we don't want to encourage that to happen either. And you know, along with that, treated lumber, you know, we want to make sure we're avoiding that, as well as you know, pallet waste or anything along those lines that could be contaminated by oil spills or anything along that. Our production line, it's 100% wood fiber. There are no additives whatsoever, no glues, nothing along those lines.
Can you take yard waste or you know, clearings for trimmings in our?
We absolutely can. The problem with yard waste is it has a it typically has a high bark content. Bark is a concern when we're looking at the ash content of our product. Now, when we intend to produce both a premium and a standard pellet, and our premium pellet has to meet stipulations that allow only less than 1% bark, or excuse me, less than 1% ash, which the bark really contributes to the ash content. On a standard pellet, the ash content is not as big of a concern, so we will carry a larger percentage of bark, and that yard debris it would fit well in that situation.
Question in the back.
Chad, are you going to be selling pellets in bulk as well, or just by the bag?
We do intend to sell bulk. Right now we're modifying our loading system to allow for a bulk loading outlet. That will be available. We're probably looking about the 1st of November to be able to load out bulk material. And at that point, I do know there is another company that we're working with that is buying a bulk delivery truck. So, very similar to a grain truck that has an auger system that would allow them to, you know, basically drive directly up to a hopper with their truck and load that material directly into your storage bin or your silo, essentially making it hands-free for the, you know, user.
Yeah. Go ahead.
I'm sorry. Are you able to utilize root log yet at this stage of your operation?
No.
So there's no way to separate the rocks and mud?
There's too many challenges. It comes in just too dirty for us to be able to use that sort of material at this point.
Do a cost analysis between your BTO per ton and, say, a ton of good coal?
We are absolutely going through that process right now. We're doing a side-by-side comparison with two identical boiler systems that can utilize both of those fuels. As soon as our facility is at the production level that we're at, we have this sample test ready to go, and we are going to do that exact cost analysis. Now, what we are seeing, or what we anticipate to see, is that because of the moisture content of the coal, we are going to, you know, be much more efficient. And then the next item is the maintenance cost of cleaning out those coal burning systems versus the maintenance cost of handling wood pellets. You know, we do expect to see a very similar cost analysis.
Yes, on the biomass, the university acre, you mentioned yield in acres per ton. Now, is this dry or moist or something? It makes a big difference of how much energy you get out.
Those numbers I showed you were dry biomass per ton, or ton of dry biomass per acre.
There's a question up high in the balcony.
Mr. Sparrow, on the, it seemed like the yields from the grasses were promising, at least preliminarily, and I'm just wondering about the water usage for growing grasses and the soil erosion in sort of that crop formation to grow those grasses year after year.
Well, certainly soil erosion, once it's established, is not a problem with something like grasses. I mean, you get a good ground cover. Water usage, I don't know. We haven't measured water usage. We do have a little bit of data on water usage for willows and poplars, not in interior Alaska, though. Actually, a colleague and I are doing some work down at Elmendorf Air Force Base, looking at water use on some old landfill caps and that sort of thing. But yeah, we haven't made any of those measurements, so I don't have any numbers there. Although some of the native grasses grow in pretty dry land areas, so they're pretty efficient water users, I think. But like I said, I don't have any data, so I can't.
Are you just letting them grow naturally, or are you?
Say again, I'm sorry.
Are you letting them grow naturally, or are you giving them a regular water cycle?
No, we don't irrigate.
Okay.
We do fertilize, but we don't irrigate.
Doug.
Yes.
You said that you were harvesting less than what the capacity is. And is that because of management, or is that because of desire and people wanting to harvest?
That is because of desire of people wanting to harvest. Yes.
So you're open for business?
We're open for business, yeah. Like I said, we're currently harvesting about 500 acres a year roughly. So, yeah, we are below what our allowable harvest amount would be.
We can't hear.
Oh,
I'm sorry, I didn't hear your answer.
Oh, we are below what our allowable cut is. We're at 500 acres a year. So
And that's based on desire.
basically because of demand.
yes.
Chad, that premium product, you just have a different feedstock, so you'd alternate running the feedstock to get a premium product or a regular product?
Yes, we'll control those separate materials in the yard.
And the input would be basically less bark on a premium feedstock?
The input is, we exclude that pile on a premium pellet.
Valerie?
For the pellet stoves, you're gonna have a higher BTU feedstock as opposed to wood, but what's the cost comparison? I mean, like, you have to use less pellets to get the same amount of heat as on a per ton basis, but is it actually cheaper to use a pellet stove as opposed to just a wood stove?
It all depends on whether you really enjoy going out and cutting your own firewood. You know, if you look at you going out and cutting your own firewood and don't apply any cost to that, absolutely it's cheaper to burn that wood. If you're purchasing it from someone that's delivering you cordwood, it's all going to come down to how much you're paying for that wood. Your efficiencies on the wood pellets are much greater, and it's a much higher BTU value coming out of the pellets than it is out of your cordwood.
What is your energy source for drying?
For drying, we use 97% of our fines to cycle back as our drying fuel. The other 3% is that propane.
And fines are consistent of?
The fines consist of the material that doesn't meet our quality spec as it's coming through the pelleting process.
Two questions. One, why Fairbanks? You know, you've got more biomass in the southeast and possible hydroelectric that can cost. Why Fairbanks?
Well, we have a very long heating season up here. There's an extremely high dependence on fuel oil up here, and the raw material is readily available here. It would be nice to be able to sit right next to a sawmill and utilize 100% of their sawmill waste, which is similar to a lot of the wood pellet facilities throughout North America. We don't have that option in the Fairbanks area, but ultimately what we looked at was making that material available here. Because if we were producing it in Southeast, it would not be more economic to get that material to the Fairbanks area where we expect it to be utilized the most.
Yeah, it does.
I guess this is probably a question for Steve or Doug, but the UAF power plant currently uses about 4 tons per hour of coal. And I'm just wondering, if you take that number into perspective and think about biomass potential, is there any potential to offload a significant amount of the energy need for even the UAF power plant into biomass?
Steve?
I mean, if you really started harvesting, if we're talking an acre an hour or something like that, I got your numbers right, Steve.
Well, yeah, I think it's probably more a question for Doug if you're talking about, if you're talking about growing biomass. But like I said earlier, we really don't know how much we can produce yet, so it's hard to say. It would certainly be nice if we could grow it right, on campus and feed it to the power plant. But until we get more information on productivity and that sort of thing, I really can't really give you an answer. Now, whether or not we can harvest, it seems to be there's a lot of wood, like from the fire mitigation sites and that sort of thing that Doug talked about, that we could could haul to the campus and use in the power plant. But as far as replacing coal, how much coal we can replace with biomass, I don't have a way to calculate that. I don't know if you have a.
Well, I think it probably would make more sense to do a supplement, like have, say, 10% of your supply be wood.
I know there are other
mixing it
university
with the
power
coal.
plants that utilize biomass. For instance, there's one somewhere in the Midwest that's near a Quaker plant. They use protocols and do, I think, about 10% or 20% protocols as opposed to coal. So they can offload some.
I've had a number of conversations with the UAF power plant as well. And, you know, in that situation, it all comes down to economics. In those large boiler systems like that, it's really tough for anything, you know, such as a biofuel to compete with the low cost of the coal that the university is able to purchase that large amount of coal for.
Question over here.
Oh, currently, the university doesn't have a way to burn biomass, do they?
Well, and Chad, you might know more about this than I do, but I think you can actually co-fire, as it's called, biomass with coal up to about 10 to 15% with you know,
The
modern coal technology burning systems.
The current boiler systems that the university has, it would take a little bit of modification in order to utilize a co-fired system, but just like you said, you know, you can, for most of those systems, they can handle a 10 to 15% co-fire to allow for some of the renewable fuels to be utilized in a system like that.
Yeah, for the professor, what type of fertilizers were you using?
Well, you mean what rates or what kinds or?
Well, a little bit of both. Were you measuring the pH of the soil and using a local fertilizer from here, or what were you doing?
No, we're using a commercial fertilizer. The primary reason for that is we want to, for now, we want to control our nutrients very carefully. So we're using commercial, you know, nitrogen, phosphorus, potassium, that sort of thing. We actually wrote a proposal to the Alaska Energy Authority a year ago to look at things like sewage waste, animal manures, fish waste, some of those sorts of things as sources of fertilizer. It didn't get funded, but that's something I still think is worth looking at because, yeah, that would be a cheap source of nutrients and probably reduce costs considerably.
Well, there's a large active lime mine in Cantwell, and I didn't know if you would.
Yeah, the pH question. The soils at the Fairbanks Experiment Farm are about neutral, so pH isn't an issue. Now we're doing some work at Delta where the soils are a little more acid, and we haven't done much, but we've done a little bit of work with liming on grasses. But we just started that study, so I don't have any information yet on the effect of liming. So some of those grasses are pretty acid tolerant, so I don't think pH would be a problem. But with some, it might. So kind of an open question right now.
And for this gentleman, what are you replanting in the areas that you're harvesting when you're taking the black spruce out? What are you replanting?
The black spruce, we're burning those windrows currently, and so when you're burning it, that actually heats up the soil, and they're coming back naturally to hardwoods. A lot of those are converting over to aspen and birch, which is what we want to do because that's less fire prone than the black spruce was. In our regular timber sale program, we're pretty much replanting the white spruce.
One more question for the man on the end. So are you burning green wood in your facility?
No, we're utilizing the dried product that doesn't meet that pellet spec, and that comes back around. So the material going into our burner is roughly 6% moisture.
And you're drying the pellets to a 6 to 7%?
Yes, yep.
So you have a big area where you're storing wood for the following year? What are you doing? Are you drying your wood on property?
Yeah,
Before you use it?
we run it through that rotary drum dryer, which dries up to 14 tons every hour.
you are taking wet wood, you're drying it.
We dry, yeah, we're buying
Okay.
wet wood
Okay.
delivered to the facility and then drying it
Okay,
through
thank
that
you.
process, yep.
So the Blue Lagoon needs to show a movie soon, so we're just gonna take a couple more questions, and Amanda, you've been very patient.
I have a question, I guess, for maybe all of you. Steve, you showing that your grasses are actually producing a high biomass, and I guess that's with a high fertilizer, possibly a higher fertilizer rate, maybe 4 tons per acre right now. Is that more sustainable than maybe the forestry harvests over time, if we were to look at it economically and sustainably?
Actually, that's an excellent question, Amanda. And we haven't done any economic analysis yet, because we haven't nailed down the productivity, some of the management questions and that sort of thing enough yet to even start to look at economics, I don't think. One of the things we are looking at is, amount of fertilizer required to grow some of these plants. And one of the important questions is, I mentioned that, for example, one of the advantages of something like switchgrass, in areas where you can grow switchgrass, is it's an extremely efficient user of nutrients. So it'll grow on fairly low fertility soils. Will our grasses do that? Maybe, maybe not. Our initial results indicate that we get a pretty big response to fertilizer. So, and those high yields I showed, that 4 tons per acre was under a fairly high nitrogen regime. So, it may take a fair amount of nutrients to get those high yields. How sustainable is it and how economic kind of depends on things like, the price of fertilizer and whether or not we can use some of those organic sources like fish waste and animal manures and sewage waste and those sorts of things. So right now it's kind of an open question. I don't know if I answered your question, Amanda, but that's kind of the bottom line is we just, like so many of these questions, we just don't have the answers yet.
As far as sustainability, I mean, the state of Alaska does an annual allowable cut for a reason. As long as we stay under that annual allowable cut, that forest will exist forever, essentially.
But I guess to what, how many rotations and how, will we get, I guess, bring up the term old growth forest? Will we lose that forest and always have a renewing forest, or will we keep some?
Well, a lot of the material that, like, for the pellet mill would be hardwoods, and hardwoods generally are younger age class. Anyway, they don't live as long as like white spruce does. So the turnover, I mean, they're basically, we manage them on like an 80-year rotation. So in nature, they generally don't live that long, just because of the nature. They're an early successional species that comes in after fire, and then the white spruce overtakes them over time. So we're really not I mean, the white spruce, the most value for like our saw logs, like Chad was saying, is basically, going to Northland wood or for saw timber, which we kind of have a market for that. And so those other species are younger, age class in nature that we're kind of looking at, both aspen and birch.
Other questions? Yes, Elizabeth.
Chad, I was wondering if you could tell us a little bit about your customer base. Who exactly are you supplying to? Is it general Fairbanks population?
For the most part, it is the Fairbanks area, but we are making material available statewide.
Are there any specific businesses?
There's a number of that are end users or sellers.
That you'll be selling them to them?
Yeah, we will be selling our product to resellers, but at this point we don't have any large-scale consumers, such as the university or the hospitals or anything along those lines. At this point anyway.
Is that a goal?
Absolutely, yeah. I'd love to see that happen.
Well, help me say thank you to these great speakers.